Hello and welcome back. In this lesson, we will be covering SQL data types and constraints. And by the end of this session, you will understand how to define the type of data stored in a database and apply rules to ensure data accuracy and integrity. Let's get started. So welcome back to this session. We'll be looking at SQL data types and constraints. Data types, we look at numeric types, text types, date and time types, Boolean type. Then for constraints, we look at primary key, foreign key, not null, unique. Understanding how to properly define table structure using data types and constraints. So let's get started. I'm going to launch Workbench. So it's time to start doing something practical. I'll launch my Workbench. Okay, before then, let's look at this. This is a topic, SQL data types and constraints. Common data types, we have VARCHAR, which is text, used for storing letters, words, and mixed characters. Examples, you want to store like name, text, or even mixed characters where you have text and numbers and symbols. So you use you use VARCHAR. Then we have integer. So use this to store whole numbers without decimals. Example like 120. So for decimal, numbers with decimals, used for numbers that require precision, especially money. Examples 10.50, 99.99, and so on. So we have date values used for storing dates in the format year, month, and day. Examples. So just like this. Then Boolean, true or false, used for storing logic values. Example, true or false, whether 1 or 0. Use appropriate data types for efficiency and performance. So for example, we have something like this, grade table students. We have name. What this means is that this particular column name, this is a column name. These students, we are creating a table known as students. Then we have name, a column known as name. Now this column is going to contain text, which is what's the data type for text is VARCHAR. Like how many characters? A name should not be more than 50 characters. So you just declare it here. You can put 100, 20, depending, but normally someone's name should not be 50. Like first name, middle name, surname. We can put 100. It depends on you. Then we have another column known as age. So this column will be used to store whole number. So we call it int. We have another column known as fee. So this one is going to be used to store amount. We can even have like decimal. So now you declare decimal, then 10,2. What this means is that the first digits before the dot will not exceed 10. And the digit after the dot should not exceed 2. You can put 1, you can put 2, you can put 5, but if you put 1, the digit after the dot will not exceed 1. So look at that. Registration date. So this column will contain date. So you declare date for it. It's active, Boolean. So you will know whether it's true or false. So let's look at it. I will click on local instance. So I already have this table created. I already have this table created already. I've declared their data types just like I've explained. Now, let me drop the table. Okay, I have a database. I will do that. When we get there, I will teach you how to do what I'm doing now. How to create database, create table, and so on. So let me drop this table. Now let me create the table again. Now this is data I'm going to insert. So I have full name, age, fee, is active, registration. So the columns I have, this first this first value will be for full name, this one for age, this one for fee, this one for is active, and the last one for registration date. So when we get to a topic for this, you learn how to do this. So now I want to insert this data. It's successful. You can see the tick I talk about, the green tick. Now, if I put what I'm going to do again, okay, let's look at it. Let's look at the table. So you can see full name, age, fee, is active, registration date. So you can see it here. Now, if I change here to, let's say I will put Paul here. If I run this, it's showing me error because this particular column for age contains whole number. That is what I declare here. I declare int, which is whole number. So I'm now putting text, so which is VARCHAR. It will not work. It won't work. So let's go back to our whole number. If I should come here and change this one to, let's say, Paul, it won't still work. It won't work because this should either be true or false. So that is the data type I declared. So when you are creating your table, you will declare data types for the columns. You will declare the data type. This is a first column, full name. It's going to contain text. So the data type will be VARCHAR, age, int, fee, decimal, is active. This one will be Boolean. Registration, date. Use appropriate data types for efficiency and performance. Constraints. So let's look at constraints like primary key, foreign key, not null, unique. Constraints, very important. Constraints enforce rules on data. Types, we have primary key, foreign key, not null, unique. They ensure data accuracy and integrity. Primary key uniquely identifies each record, cannot be null. No duplicates allowed. So if you have, okay, this is a column name, ID, data type int, you now declare a constraint primary key. It means that this column cannot contain null value and there should be no duplicates. Now we have foreign key, links one table to another, maintains relationship between tables. We have foreign key, like the customer ID, references ID in the customer's table. So just like Power BI relationships, where you use the common fields, common columns to create relationships between two tables. So that's the same thing that is happening here. So we have not null, ensures a column cannot have empty values. Now we have the column name is first name, VARCHAR, data type. So we now have not null. So this column cannot have empty values. We have unique, ensures all values in columns are different. Like the column name is email, VARCHAR, then now you now add a constraint unique. So it means that this column cannot have the same email address. Okay, so let's look at this. Let's look at the example. I'll go to Workbench. I'll scroll down. Okay, I'll create. So this is it. I have the column name ID, data type int, and now declare a constraint known as primary key. That means that this column cannot contain empty values and also no duplicates. So I have this one, the column first name, VARCHAR, and I say not null. It means that this column cannot have empty values. Last name, the same thing. We have email, VARCHAR, it means unique. They can't have the same email. And I now have department ID int. I didn't declare any constraints here. So I have a foreign key, which is department ID. Referencing, I have a table known as departments. So it's referencing the ID column in the departments table. So that's what it means. So now let's look at this. Okay. Let me remove this. If I run this, so our table contains, okay, let me create the table first, then it works. Okay, let me drop the table, create it back. So now let's look at something. If I, in this particular ID column, say that it cannot have not null and no duplicates. So if I put 1 here, that means we have duplicate values here. I have 1 here, I have 1 here. If I should run this, it won't work. You can see now they are telling me duplicate entry 1. So it won't work. We drop it. Now let me change this. This particular column cannot be null. Let's say, for example, let me copy this. Okay, let me change this to like 2. This one cannot be null. So if I declare null here, for example, you can see now this column not null cannot be null. So if I declare null here, it won't work. So you're having error. They're telling me cannot be null. It won't work. So let me remove the null. Let me put something else. Let me put Joe. So it will work now. So now this column, the same thing, cannot be null. This one now, we can't have the same email. We can't have the same email address. You can see now we have this email, this Jane Smith, the same email. If I run this, it won't work because it's a unique. This email VARCHAR unique, so we can't have the same email in that column. It's not working. You see now they are telling me duplicate entry Jane Smith. So if I change this to, let's say, Julie, if I run it now, it works. You can see now it works. It works. So you can see the last one. I have one here, I have one here, but there's no error because no date, no constraint was declared. I didn't declare any constraint in this particular column. So I can even enter duplicate values. There was no constraint. I can even enter null. So no constraint was declared here. So constraints ensures data accuracy and integrity, like you have seen in the illustration that we just did. So that is it about data types and constraints.